Hey guys, I'm going to talk to you today about tools for evaluating process performance. And I tried to work on this presentation because I gave it to you on Tuesday and it wasn't so good. So today we're going to talk about key relationships, thinking with equations, base case ratios, and graphical representations. We're going to connect this to how it will help you with evaluating your process. So some key relationships you can look at are on table 17.1, page 594. And this talks about the situation, the equation, some trends, and comments. So for instance, it will give you a situation like that you are losing, your fluid flow is slowing down due to friction loss. And it will give some key simple equations and some typical trends you'll see. When you're working with equipment, there's some things that, and you're evaluating performance, there are some things that you should not do. The main one is, do not use extensive detailed equations. You want to use simple relationships, something that can help you find the problem quickly and make a good relationship and help you find a rough estimate. For instance, if you're using a detailed equation that gets you 16,010 cubic feet, that's not much different than using an equation or a ratio that would get you 16,000 cubic feet. A method you can use for solving problems is GINI. GINI stands for goal, equation, need, and information. You need to determine your goal, and you also need to find an equation that fits the problem you're currently working with. And from there, you need to determine the information that you need. And from there, you'll take an action, and you'll find the information that you need. You'll use the information and plug it into your equation and see if that achieves your goal. If it doesn't, then you need to determine a new equation, determine your need, and use the information, plug it back into the equation again, and see if you achieved your goal. We talked about not using very detailed equations. What this tool for evaluating process performance, a lot of times it's used when you're in a situation at a factory and something's happened and you're dealing with a symptom. And a symptom could be anywhere from an explosion and having product all over the floor. And you have to patch it up. So you want to find a quick solution. How you can do this is eliminating detailed equations and using ratios. Ratios can relate to equipment sizes. For instance, if you have a smaller piece of equipment that uses so much energy and you have a slightly larger piece of equipment, you can determine how much energy needs by using ratio. This also reduces the need to know the exact values. So for instance, going back to the 16,010 cubic feet versus 16,000 cubic feet, there's not much difference. When you're evaluating your process and you're trying to find a problem and find the solution, using graphical representations can help you. An example would be if you're losing fluid flow, using a Moody diagram and showing the people how the friction factor relates to the real number. For instance, if you increase the friction factor, you're typically increasing the pipe roughness, which will slow down your fluid flow. So here's an example of a Moody diagram. So you can show them how the relative roughness relates with the coefficient factor that you're dealing with. Other tips you can use when working with a Moody diagram is not always depend on color. For instance, you see these are all red, but when you're trying to point out something specific, bold the specific line you are working with. And try to use something other than color because not everyone can see the color. Another graphical representation for communication could be using pressure drop versus velocity. So here's the diagram from the book. Let's say if you're working on something and you want to increase the velocity from 2 meters a second to 3 meters a second. What does that do to your pressure drop? The pressure drop increases. Or, for instance, if you want to compare changing pipes and increasing the velocity, you can compare them. You can put two on one graph. Another diagram that can be used for communication and evaluating your process tools is a TQ heat exchanger. This is good for, as we stated, performance, but also as an energy balance. So when you look at this one, you can tell right away that the minimum temperature it goes down to is 100, and the highest is 400. This is the driving force. We were recently told that a good heat exchanger will have less than 100 degrees Celsius difference right through here. So when you're communicating and evaluating the process, someone can look at this and see that it's not too efficient by showing these two things here. So in summary, when you're evaluating a process and you're using your tools, you want to determine the goal, the equation that fits the situation you're working with, the information that you need, and then gather that information. You also want to use graphs and to improve your communication. This gives someone a visual aid in addition to just staring at numbers. And you want to use simple equations because it will not only will it save you time, but it helps find you can help solve the problem faster.